learners, welcome to the next module of quantum k-means clustering algorithm. So here we are going to discuss about quantum k-means clustering and quantum k-means clustering approach and what are the challenges and what are the advantages and limitations for a real-time application. So what is k-means clustering? K-means is an unsupervised learning algorithm. So in the case of unsupervised learning algorithm, the model that are used to find the hidden pattern and hidden structures in data without thinking about the labeled outcomes. That means data does not come with predefined classes or label. So in k-means clustering, the algorithm attempts to group data points into clusters, group of datas, based on the similarities without any prior knowledge. So for example, in real-time application, we can similarly match the related articles to the different kind of clusters. What is k-means unsupervised algorithm? In supervised learning algorithm, the algorithm is trained on the dataset where the outcomes are provided. The goal is to learn mapping the input features to these labels. In contrast, k-means clustering does not use any labels. So we are going to group all the data points into k clusters to minimize the variance with each cluster. Here this k-means clustering algorithm is very important to for all real-time application to group all related articles. For example, the user is searching for a similar book and data. In k-means clustering, we can have a different kind of steps are there. The first one is input, only a set of data points, no labels are needed. Goal, identify the structure in the data by grouping into k clusters that are similar to each other. Output, the algorithm outputs the centroid of the cluster and the assignment of each data points to the specific cluster. In k-means clustering, first we are going to think about the initialization. Select k initial centroids randomly. Assignment step, assign each data point to the nearest centroid. The nearness is usually measured with the distance metric. We have a different kind of distance metrics are there. Here we are used Euclidean distance. Update step, in that step, after assigning each points to the cluster, update the centroids by taking the mean of all points assigned to each centroid. That is very important to keep on the update of the distance. And we are going to repeat the assignment and update the steps until the centroid no longer changes scientifically. So we are going to think about the result in that once the algorithm coverage is over, each data point is assigned to one of the k clusters and the centroid of each clusters are calculated. So in the repetition step, the assignment and update steps until the centroid no longer change significantly. So that is, we need to think about that. So for example, consider a dataset. In the dataset, customer purchasing behavior is added. And here we are going to group the customer into cluster based on the high, who are all buy more related products and who are all stay at the same product for a long way in that website. And K means can automatically group clusters based on the purchase patterns without any prior labeling. So purchase pattern is very important to keep on update of the online e-commerce application. So key points here we are going to think about no label data, finding structure of the data and dimensionality detection. This K-means clustering applications are customer segmentation, so grouping of customers based on purchasing behavior and demographics, image compression, reducing the number of colors in an image by clustering similar groups. We can easily go with that. Anomaly detection, identifying unusual patterns or outliers by seeing which points do not belong to any customer cluster. Market basket analysis, that is very important for purchasing any items. So first of all, what is clustering? Grouping similar data points. Grouping similar data points into the cluster based on the similarity measure. K-means is one of the popular clustering algorithm. Now why we are going to quantum K-means? Quantum computing offers significant speed up. With the help of this quantum computing, we can easily do optimization problem in a very faster manner. So handling large data sets and high dimensionality data efficiently, we can easily do that. So what are the difference between classical and quantum k-means clustering? In classical k-means, we are going to find out the k clusters centroids randomly, assign each data points to the nearest centroid, update the centroids based on the cluster average, and we are going to find out the complexity. We are going to repeat the steps until we are find out the similar distance. So order of n times of KID. So K is n points and K is a cluster and n is the data points and I is the number of iteration what we are doing, and the next is D is a dimension. And next is in the case of a quantum K means we are going to measure the quantum distance computation and superposition to evaluate the multiple cluster assignments simultaneously. Potential exponential speedup is reached here. So in quantum K-means approach, we are going to use data encoding, distance computation, cluster assignment, centroid update, iteration, and coverage. So assignment convergence is also very important here. Data encoding, encode classical data into quantum states using amplitude encoding. We are having a different kind of encoding methods are there. Distance computation, compute distance between data points and centroid using quantum gates. And cluster assignment, use quantum operations to assign data points to the closed centroid. Centroid update, we are going to do the aggregate of cluster members and update centroid frequently. Iteration and convergence, repeat the steps until the cluster assignments is stabilized. And here we are having algorithmic view. Initialize the centroid, select initial cluster centroid, quantum distance calculation using quantum circuits to calculate distance efficiently, assign clusters, assign each data point to the closed centroid, update centroid, compute the new centroid based on the assigned clusters, and convergence repeat until the centroid stabilize. So in the initial centroid, classical K-means begins by randomly selecting K centroids from the data points. Quantum K-means can similarly begin with the classical step, but in a quantum version, centroid may be represented by quantum states, quantum bits or qubits. Quantum superposition, the centroid may be initialized in a superposition of multiple possible centroids location. This means that multiple possible centroids are considered here. So we may have a multiple centroids here. So with the help of quantum states. So here we have a two centroids are there with the help of quantum state. So centroid is calculated with the help of alpha and beta quantum amplitudes. Here we have a 2 points are there x comma y. Here we are going to consider about x1 and y1 and x2 and y2 are the possible centroid states. Quantum distance calculation to be calculated with the help of distance measure. What we have discussed in the classical K-means clustering. In quantum states, quantum circuits can allow simultaneous calculation of distance for all centroids using quantum superposition and parallelism. In quantum parallelism, operations can be done in multiple positions, data points, and centroids in the quantum states. So example, we can use a quantum gates to compute the squared Euclidean distance between quantum representation of each points. If there are k centroids, quantum computing could calculate k centroids at once, reducing the computational time and compared with the classical methods. So with the same similar to classical methods, quantum also to be measured assigns clusters. Quantum measurements also there to compute all kind of quantum superposition state. So here this is identical in quantum K means, but use quantum measurement to decide which centroid is closest here with the nearest center. Next we are going to update the centroid with the help of a set of points assigned to the centroid J, and Nj is the number of points in the centroid. Quantum step in quantum methods can be used to update the centroid efficiently, and quantum circuit could compute the quantum average of the point in the cluster. Quantum state may represent the clusters. Quantum operation can compute the new centroid in parallel. So first step we are going to do the cluster assignments, and the second we are going to calculate the quantum Euclidean distance computation. This is one of the example, and we can also use Euclidean distance to compute the distance between 2 points, and encoding mechanism, quantum encoding mechanism also to be implemented. And here we can have the sample distance quantum measurements also to be used. Squared Euclidean distance is mapped to the quantum measurement outcome, and we can also go with that. case of computational complexity of a classical K-means, we can go with the order of M and K. M is the number of data points, N is the number of features, and K is the number of clusters. Advantages of using this K-means clustering using quantum speed up, because quantum parallelism accelerate distance calculation and cluster assignments to be happen with the help of quantum gates. Efficiency handles a high dimensional data effectively, and scalability, we can easily go with a large kind of data sets. Challenges, definitely we can go with quantum hardware constraint is there. Current quantum devices have limited qubits and noise issues. So data encoding complexity is also to be there, and algorithm complexity also to be there. So this is the very simple introduction about K-means clustering algorithm using quantum computing. Thank you learners. We will see in the next algorithm.